In this video, I'm going to look on Gauss-Jordan elimination method of solving systems of linear equations. So here's our problem. For which values of C with the following system we have the first part no solution, second part exactly one solution, third part infinitely many solution. So this is our system of linear equations. The first one is x plus 2y minus 3 is equals to 4. Second one is 3x minus y plus 5 is equals to 2. 4x plus y c squared minus 14z is equal to c plus 2. So what we're going to do first, we're going to try this problem as a matrix, and after that we're going to perform some row operations and reduce the matrix to row echelon form, and after that we'll be able to solve our problem, right? Okay, so let's write this as a matrix, right? So as you can see, I just taken the coefficient of x, y and z. So if we have nothing, then the coefficient is 1 right here, okay? And that one is the right hand side, right, for the equal sign. Okay, I'm just going to make this a single matrix, right? Okay, so here's what we have. So to reduce this to row echelon form, what you need to have 0 right here, and we need to have 0 right here, and we need to have 0 right here. So I'm going to use operations to rewrite our matrix or to reduce it to row echelon form. Okay, so what I'm going to do, I'm going to start by solving this 0, then go to this 0, and finally finish with this 0. Okay, that is the sequence that I like to work with. Okay, so now here I have 3 and here I have 1, and that is like when you have 1 right here. If you have a number, just go to reduce it to 1. Why? Because if I need to make this row equal to 0, I'm just going to multiply this row by 3, right? So if I multiply this row by 3, I'm going to have 3 here, and here I'm going to have 3, right? If I subtract, I'm going to have 0. So that's what we're going to do. I'm going to multiply row 1 by 3, then subtract row 2, and this operation you have to state which row is the operation affecting, and mine is affecting row number 2. Okay, so now what I'm going to do, I'm just going to substitute the values for row 1 and row 2. Row 1 is not going to be affected and row 2 is not going to be affected. So I'm going to write my unaffected rows right here. As you can see, for row 2 I have nothing right here, but I'm going to fill it. Okay, so now let's go. So first of all, I'm going to look at this column. For row 1 we have 1, for row 2 we have 3. If we substitute, we're going to get 3 minus 3, that's going to be equal to 0. Now I'm going to go to column number 2. For row 1 we have 2, I'm going to have 7. It's going to be 3 times 2, and we have a negative right here, but also we have negative 1 on row 2. Okay, so negative and negative give us positive, right? So it's going to be 6 plus 1, and that's going to be 7. And we have 5 for row 2, right? Okay, so now negative 3 times 3 is going to be negative 9. Negative 9 minus 5, that's going to be negative 14. And now let's go to the last part, right, which is the last column right here. 4, that is going to be the first column, which is row 1, and for row 2 we're going to have 2. So by substituting, we're going to have 4 times 3 minus 2 is equals to 10. Okay, so now let's substitute our values in our new matrix, as you can see. So that's what we have. Okay, so now we're going to go to this row. So now we have row 1, and we have 1 here, and right here we have 4. Okay, so what you need, you're just going to need to multiply this by 4, right? Because if you multiply this by 4, what we're going to get, we're going to get 4. And if you say 4 minus 4, we can finally have 0 right here. So we're going to say 4 row 1 minus row 3. Okay, so let's do that. Since I said this is going to affect the third row, I'm going to write unaffected row, row number 1 and row number 2. Okay, so let's write them here. As you can see, we have nothing here. We have to calculate the values first. Okay, so now let's go to column number 1. For row 1 we have 1, for row 3 we have 4. Okay, so let's substitute. So we're going to have 4 minus 4, and that is going to give us 0. Okay, let's go to column number 2. Row 1 we have 2, row 3 we have 1. Okay, so if we substitute, we're going to have 4 times 2 minus 1, that is going to give us 7, right? Okay, now let's go to the third column. So for the third column, for row 1 we have 3, but for row 3 we have c squared minus 14. So we're just going to write this as 4, right? Okay, so what we're going to do, right, you have to take note of the negative signs, right? So 4 times negative 3, that's going to give us negative 12, right? There's no problem right here. And we're going to have negative c to the power 2, right? But if you see negative and negative, it's going to give us positive 14, right? You see, if we simplify here, you can see that we're going to have 2 minus c squared, right? Okay, that's what we're going to have. Now finally, let's go to the final column. So for row 1 we have 4, and for row 3 we have c plus 2. Okay, so I'm going to say 4 times 4 minus c, and we're going to distribute negative sign right here. So we're going to have 16 minus c minus 2. So it's going to be 14 minus c, right? If you say 16 minus 2. Okay, so now let's write our values. Okay, so this is what we have. And luck for us, you can easily say row 2 minus row 3, or row 3 minus row 2, and we're going to have 0 right here. Okay, if we go to the second column, what we're going to do, we're going to say 7 minus 7, we're going to get 0. let's go to the third column. So for the third column, we have negative 14, right? And here we have 2 minus c squared. So if we distribute the negative, we are going to see c is going to become positive and 2 is going to become negative, right? So we're going to have negative 14, negative 2, that's going to give us negative 16, and our c is going to be positive. What we have 10 for the second row, minus, right? I put a bracket since we have some expressions right here. Okay, so negative and negative, we're going to see that c is going to become positive, right? 10 minus 4, that will give us negative 4, so it's going to be c minus 4. Okay, so now let's write our matrix. Okay, so now this is our reduced matrix. Okay, so from here we can now solve our system of equations. So this is the value for x, this is the value for y, this is the value for c, and right here you can see this should be equal to this for c. Okay, so now let's look at our equation. For which values of c with the following system you have no solution? Okay, so for this system to have no solutions, that means right here we need to have 0. Okay, but don't need to have 0 right here, we need to have a number which is not 0, right? Okay, so I'm going to write these conditions. So for the first one, for no solutions, negative 16 plus c squared should be equal to 0, but c minus 4 should not be equal to 0. Okay, so let's solve for c squared right here. Okay, so you can use factorization, but what I'm going to do, I'm just going to move 16 to the other side and take the square root of 16, and it's plus or negative 4. Okay, then let's go to this condition. We're going to have c can be equal to 4. If we put positive 4 right here, this we have no solution at all, right? To have exactly one solution, what is going to happen? Okay, so what we don't need 0 right here, and also don't need 0 right here. Okay, we need to have a number. Let's say if we have 4 and right here we have 8, so you can say 4 c is equals to 8. So let's write these conditions. So you don't need positive 16 minus c squared to be equal to 0, right? Okay, so this should be positive. Okay, and the other thing, we don't need c minus 4 to be equal to 0, right? That can be not equal to 0. So if we solve, we have solved right here, and if we solve this, we're going to see that c cannot be equal to plus or minus 4, and so for this we're going to see that c cannot be equal to positive 4. So that means we don't need the values of c to be positive 4 or negative 4, but all other values are valid, right? Okay, now this is going to be our final statement, right? C cannot be equal to plus or minus 4. Now let's go to the third part, right? Okay, so for third part, what you need to have infinitely many solutions. So that means if we have 0 right here and we have 0 right here, that means c is going to become a free variable, right? That means you can have as many solutions as you want, right? Okay, so that means we need positive 16 minus c squared to be equal to 0, and at the same time we need c minus 4 to be equal to 0, right? Okay, and if we solve right here, you see that c should be equal to plus or minus 4, and right here c should be equal to 4, right? Okay, so that means we're going to take the conclusion, right? So to have 0 right here and also to have 0 right here, we need our c to be only positive 4, right? Okay, because if you put negative 4 right here, you're going to have negative 8. Okay, thank you for watching. Do me a favor by subscribing.